problem D1, we solved this with FORM before. Now we are going to solve this with SORM and see what sort of improvement we might be getting. Let's take a few seconds to read the problem statement and then we'll present the solution. So this one is a 4 random variable problem, and there is a dependence between D and Q, the two loads. Now we discussed in detail how we employed the Nataf transformation, how we solved it using the MATLAB function fminconst. So we are not going to go into that. We'll just present the FORM results obtained from this Nataf transformation, and then from that point onward we are going to derive the corrections necessary for SORM. If you would like to solve this yourself, please pause the video, and otherwise let me present the answers step by step. So this was our limit state x1 x2 minus x3 minus x4, and we minimized the problem in the distance in the independent standard normal space and obtained an U star, as you see on the screen, negative 1.39, negative 0.6, 1.13 and 0.07, and the beta was about 1.89. So that is our starting point. And again, after doing the eigen analysis, or something equivalent, we get this curvature, which for the first one is almost 0, and the two other ones they are both negative. So that gives us an equation of the paraboloid in terms of u1 tilde, u2 tilde and u3 tilde, drawing a surface above the u4 tilde axis, if you will. And this gives us the 3 principal curvatures that we can use to get the correction factors, and that's what we see. The value of phi of negative 1.893 obtained from form, corrected by 3 factors. The first one is actually slightly less than 1, but the other two, the second and the third ones, are greater than 1. So looks like we are going to have a higher failure probability when we employ the SORM corrections, and that's the answer, 0.036. And if we find the equivalent beta by inverting the normal CDF, we get a beta in SORM, an equivalent beta of 1.788 instead of 1.893. So again, this time SORM reduce the reliability estimate, increase the failure probability, and let's see if it is closer to the accurate value. Again, accurate in the sense it's from our Monte Carlo estimates, but we have been saying that if the sampling is done properly and if we do a large enough number of samples, then by the law of large numbers we should be getting closer and closer to the true value from MCS. So let's see how close or not this is. Well, it turns out to be it's rather close. The beta from MCS is about 1.77. The beta from SORM is about 1.79, whereas the beta from FORM is 1.89. So in all these examples that we have been seeing, SORM does seem to be making a good correction to the errors in FORM. Now, obviously, there are many issues, including how many curvatures there are in the surface, in the limit state surface, if there is a point of inflection or not. All these things would tell us what sort of or what quality of correction SORM is doing. If there are multiple local minima, all these things are a little advanced in nature and beyond the scope of this course, but I have shared some of the papers for further reading, and you will be able to get more information from them.